Hello students. So we will continue the lecture from where we have left, that is the conversion part. Okay. So we saw how we can convert a decimal number to its binary equivalent or octal equivalent or hexadecimal equivalent. Now we will see how we can convert a binary number to a decimal equivalent, octal number to its decimal equivalent, or a hexadecimal number to its decimal equivalent. Okay, so we will cover that topic today. But before that, I want to show you this. Suppose you have a number like 19.35. It's a decimal number and you want to convert it into its binary equivalent. So how are you going to do? Now, I have already taught you for number 19, right? How do we do this if you have only 19? We take number 19 and we divide it with 2. So if we do that, 2 9s are 18, remainder 1. 2 4s are 8, remainder 1. 2 2s are 4, remainder 0. 2 1s are 2, remainder 0. And we take it from MSB to LSB, that is bottom to top. What do we get the answer as? 1 0 0 1 1. So this will remain as it is. Okay, this will remain as it is. Then we give a decimal point. Then we take the numbers after the decimal point, that is 0.35. What are we going to do with this 0.35? We will multiply it with 2. Okay. Here we were dividing it with 2. Here what are we going to do? We are going to multiply it with 2. So 0.35 into 2. What are you going to get? You will get 0.70. 0. So my digit will be 0. Now 0.70 into 2. What are you going to get? 1.40. So before the decimal, we have number 1. Now I'll take 0.40 from here. So 0.40 into 2. What are we going to get? 0.80. So before the decimal point, number 0. Then again we have 0.80 into 2. So answer will be 1.60. Before the decimal, 1. You can continue this till you get a whole number 1, or you can stop it till here. Okay, 4 digits more than enough. The only difference over here is, here we were doing MSB to LSB. Here we will do LSB to MSB. That is from top to bottom. Okay, from LSB to MSB. All right. So what do we get? 0, 1, 0, 1. Clear? Understood? Let us see one more example. Let us take a number like 195.25. Yeah. Okay. So we have to convert it into its binary equivalent. How do we do it now? Again, we will take first 195. 195 divided with 2. So 97 remainder 1. 48 remainder 1. 24 remainder 0. Please try it on your own. 12 remainder 0. 6 remainder 0. 3 remainder 0. And finally 2 ones are 2, remainder 1. MSB to LSB. So 1, 1, 0, 0, 0, 0, 1, 1. And we'll give a dot. Okay. And then we'll take 0.25. What do? We multiply it with 2. What do we get? 0.50. What is before the decimal point? 0. We write 0 over here. Then we take this 0.50 and multiply it with 2. What do we get? 1.00. So what is before the decimal point? 1. Now when you get A number like this, like 1.00, there's nothing after this decimal point. If you take 0.00 and multiply it with 2, you'll get the answer as 0. Okay, so we stop here and 0, 1, LSB to MSB. So this will be your answer. Clear all of you? Okay, so this is what I wanted to explain you guys before I start binary to decimal and other number systems to decimal. So let us begin with binary to decimal. Binary to decimal. Okay, now binary to decimal, how are we going to do that? Let us take a binary number. Okay, number 1, 1101. It's a binary number. You see the base is 2. So it's a binary number. What are we going to do? We are going to convert it into a decimal number. Alright. So how we go about? What are the steps? First, write down your binary number like this. Now, start from 0. So this is 0, 1, 2, 3. Alright. So what are we going to do is take this number, number 1 into 2 to the power of 3. Alright. Plus again a number 1. So 1 into 2 to the power of 2. Plus we have a 0. So 0 into 2 to the power of 1. Plus we have a 1. So 1 into 2 to the power of 0. Okay. So now when you calculate this, 2 cube is 8 plus 4. This will be 0. So 0 and this will be 1. So answer is 30. So 1101. This is a binary number and its decimal equivalent is 30. Is it clear to all of you? Let us do another one so that you get a clearer picture of it. So let us take a bigger number, okay? 1, 1, 0, 1, 0, 0, 1. Okay, again I'll just label it with a different color so it is clear to you. 0, 1. You don't have to do it I'm doing it for you to understand. Once you understand, you don't have to label these numbers like this. Okay, so yeah, this is only for your understanding. Okay, so now I'll start from here. 1 into 2 to the power of 6 plus 1 into 2 to the power of 5 plus 0 into 2 to the power of 4 plus 1 into 2 to the power of 3. I hope you all understanding how I'm doing it. 1 into 2 to the power of 6 plus, again I took this 1, 2 to the power of 5. Then I took this 0 into 2 to the power of 4 plus 1 into 2 to the power of 3. Then next digit is 0. So 0 into 2 to the power of 2. Again we have a 0 into 2 to the power of 1 and then 1 into 2 to the power of 0. Alright. So if we calculate this, what are we going to get it? This will be 64 plus 32 plus 0 plus 8 plus 0 plus 0 plus 1. That is going to give us 105. So the answer will be 105. So this is a binary number and its decimal equivalent is 105. I hope it is clear to all of you. How do we go about binary to decimal? Now we will see how we can do binary to octal. Okay? Binary to octal. So when we say binary to octal, we have to first take a binary number. Okay, so let us take a binary number 101001. Yeah, this is a binary number. Now what do we need to do it? We have to convert it to a octal number. So how do we do that? How do we convert it to an octal number? Let us see that. Binary to octal is done. The first step is you convert it to step 1. Step 1 will be convert this binary number to a decimal number. Binary to decimal. And then convert step 2. Convert decimal to octal. Okay, that will be pretty easy. We can convert a decimal number to an octal number. We have already learned that. So let us see how do we do it. Binary to decimal. We have just learned 1. If you want to label that, let us label it 0, 1, 2, 3, 4, 5, 6. Total 6 digits. So 1 into 2 to the power of 6 plus 0 into 2 to the power of 5 plus 1 into 2 to the power of 4 plus 0 into 2 to the power of 3 plus 1 into 2 to the power of 2 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0. Okay. So in this way, what are you going to get? You will be getting, if you just multiply and add them up, I'm writing it directly, you'll be getting 85. So this is how you converted a binary number into a decimal number. So now we already know that how do we convert decimal to octal. I hope you all remember. We'll take 85 and we divide it with 8 because we want an octal number. So again, you just divide it by 8 all the time and get the remainder. So suppose 8 tens are 80. So we get the remainder as 5. 8 ones are 8. So the remainder is 2. Okay. So from MSB to LSB, 125. So the answer will be 125 and the base will be 8. So this is the octal equivalent of this binary number. How do we do it? We first convert binary to decimal and then decimal to octal. In the same way, we can do it for hexadecimal also. If you want binary to hexadecimal, then the step 1 would be binary to decimal and then decimal to hexadecimal, the way we do. All right. So I hope it is clear to you all. That's all about conversion. I'll be uploading practice questions, some few practice questions I'll be uploading in the description box. You can click on it and you can practice those questions. Okay, if you face any problem, please mention it in the comment section. Thank you and take care.